All right. Looks like we are live. All right. If you can hear me, put a plus in the chat for me so I can see that you're here. We did start a couple seconds early. So, again, if you can hear me, put a plus in chat. Travis, Eden, Jason, Amelia. Wow. I love the enthusiasm, love the excitement today. Those multiple pluses. Amazing. Let's see. We just had our first live lesson yesterday playing with fractions. So if you were there yesterday and you're back, you're returning, let me know. Holler in the chat. But if you're new today, say hi. Let me know what's up. Introduce yourselves. Let me get to know you a little bit. How are we doing today? Hopefully my mic is working okay. I see all the pluses. We already have a top chatter here, Amelia. I've never been here before. Welcome, Amelia. Welcome. Hopefully I'm pronouncing your name okay. I was debating a little bit, but thank you for being here. Amazing. Anyone else new here today? Say hi. What's up? Welcome to today's stream. Yes, it's correct. Amazing. Awesome. Thank you for participating. Yeah, Jason, welcome. All right, well, I see there are a couple of newbies in the chat. Let's keep that energy throughout today's lesson. LA Santa Monica, wow. New Jojo, Brian, welcome. Welcome, welcome. Well, you're in the right place if you're here for Algebra 1 today, our very first free live lesson for Algebra 1. Really excited to share with you what we have today. Today, we're going to play with substitution. And before we begin, just a reminder, if you have your workbooks that were sent to your email about 30 minutes ago, go ahead and download that. Or if you don't have that already downloaded, the workbook link is actually down in the YouTube video description. So down below, you'll see the link to the workbook. They're professionally designed workbooks that you can use to follow along in today's lesson. And this is what you'll be getting for every single lesson here on out if you join us here at My Headspace. All right. Before we start, have any of you heard of this topic, systems of equations by substitution? Maybe you've heard of substitution before. Maybe you've heard of systems of equations before. Anything like that. Have you heard of this before? Or how many of you have never heard of this before? Amelia has heard of it before. Great. I'm expecting you to absolutely crush today's lesson then. Help out everyone in the chat whenever they have a question. You can feel free to @ them. Amy, it scares me. No, don't be scared. I'm going to make you feel so good after this lesson today. Wow, that makes me even more excited. I miss the feeling of when I used to learn something new in math and it clicks. Wow, that feeling is possibly the best feeling in the entire world. And when I teach it, I get that same high every time as well. But I'm jealous for you because I'm sure if you've never seen it before and it clicks today, man, what a treat. I'm excited for you today, Amy. Okay, well, before we move any further, let me tell you a little bit about myself. Nabil, welcome. Oh, welcome back. I remember you from yesterday. Let's get clicking. I'm Eddie. I've been teaching for 9 years in both high schools and colleges. I've also been a private tutor for every subject starting from 6th grade math. I did really well in school. I got all A's in my math courses, got a perfect score on the SAT, and got into my dream school, UCLA. Graduated with a bachelor's degree in pure mathematics. Yes, I'm a math nerd. I love math. But more than math, I love teaching it more. My students have gotten into the top universities. They've passed with flying colors on state exams, exceeded the standard, got 5s on their AP exams. But most importantly, they had fun along the way. And that's what we're here to do today. We're here to have fun. It's my job to make math fun and approachable, to make you all the next generation of math geniuses. Amelia, you don't really like math? Well, with me, I'm sure you will find and rediscover the beauty of math, because right now you may not like it, but I assure you, when you first saw it in elementary school, maybe even as a toddler, you love patterns. Math, by definition, is the study of patterns. And who doesn't like patterns? Who doesn't like puzzles? And when things just work out the way they do, and when we discover that, it's just so beautiful. And I'm so excited for you today, Amelia. It works, I can check. I love Matt Chonghwa, welcome. Yes, I am Korean, so if you have any Korean names, I will be able to pronounce them correctly. UCLA is your dream uni. Yes, UCLA is an amazing school, super diverse, top education. It's possibly the top public school in the entire world. Not biased. But before I move on, copy the URL in the top of your browser, send it to a friend that might want to join the fun today. We're about to have so much fun, so you don't want your friends to miss out. Send it to a friend, and while you do that, let's get started with our vibe check. I love starting my lessons with a vibe check. Boost the mood, boost your confidence, get our gears running, get our brains activated. What do you think these 4 images have in common, or how are they different? It kind of looks like I'm older and I need help. I have 2 kids in high school freshman year. Well, Star Pause, you're here for a treat. I'm here to show you what I'm all about, what my Ed Space is all about. I'm so excited for this lesson today. Vibe check. 5th grade. Well, we just had our grade 6 through 8 math lesson yesterday, so you can check that out as well. You can also check out the link in our YouTube description. We have 4 courses available, and more on that later. But right now, I see 4 images on my screen. The first one looks something like a business owner maybe selling something online. They got the coffee. You're gonna need, caffeine to get you started when you're running a business. In the second image on the right, I see a bridge with a bunch of poles connected, maybe some parallel lines, maybe some linear equations in there a little bit. In our third image, I see some traffic. We love LA for its traffic. Without traffic, it's not LA. Builds so much character, road rage, and everything else. It's amazing. And in our fourth little GIF here, you see 2 graphic items that look like they are colliding, but not really at the same time, right? There looks like there's an error in the code when the box is sliding back. I like these little puzzles. Yes, for coding. Yes, today we're talking about systems of equations using substitution, and all of these use some type of either substitution or systems of equations. Yes, train. Yes, this looks like the top of a train track, right? This top right image. Amazing. Are they all about ratios? Ooh, we just talked about ratios yesterday. And yes, ratios can be used for all 4 of those as well. Wow, I just got super excited because you are correct about that as well. But it has more to do with what we're talking about today. In business, when we have supply and demand, when those 2 curves intersect, when they meet, that is the optimal way to run a business. When we have train tracks, you see those parallel lines. We're talking about slopes of linear equations. And when we substitute them into one another and see these points of intersection, you might have heard this phrase that I said multiple times already, points of intersection. These will be crucial to today's work. If you look at the traffic, the freeway and the street, they're perfectly designed to intersect at some point, so they do not cross. So we find that point of intersection and make sure they don't cross at that point for city planning, engineering, things like that. In gaming and computer science, I'm sure a lot of you are into that as well. It looks like there's an error in the code here. It's because they did not take into account the bottom part of the box with the red item colliding. And that is a point of intersection issue used by solving systems of particular equations. Ooh, let's keep it going. I love to start off my lessons with an APK. These are called accessing prior knowledge. We love to boost our confidence before going into something that might look a little more difficult or a little intimidating. So that's why I like to add these in, give ourselves a pat on the back when we get this, and lead us into some more challenging and difficult concepts that I will make super accessible for you today. If I can find my pen. This happened to me yesterday as well, but we're looking for Waldo here. Wow, it was literally just here. Oh, there it is. It was camouflaged with my keyboard. Great. Let's get started. Let me catch up with chat here. I have to do well with that today. How's it moving? How's it GIF? Are they all about ratios? How long is this? This is going to last until 6 p.m., just 1 hour, and you're going to be surprised how fast this hour goes today. Is X up, R is Y? All right, let's get started. APK. Part A, draw the lines y equals negative x plus 1 and x minus y equals negative 3. Under 50 minutes or so, you won't want to miss one. Yes, thank you, Levi. On the same coordinate axis, we have y equals negative x plus 1. If you're familiar with linear equations, you know that this is in slope-intercept form. What is our slope for this first linear equation right here? Y equals negative x plus 1. Can anybody identify the slope of this line for me? You like my glove? Thank you. It helps to not, because my hands tend to get a little sweaty when I write. So on the pen pad, it makes it a lot smoother. Ooh, Jojo, Brian, Amy, super quick with it. I love the speed here. Chonghwa, same as you. Slope is negative 1 here. The slope is always the coefficient of the x variable once everything has been simplified. So here, negative 1 is our slope. So that's how fast or at what speed our slope will be increasing or decreasing. Hi, Daniel. Okay, I'll try to remember that. Welcome, Daniel, on your mom's account. Awesome. Plus 1. What does this 1 stand for then? This plus 1. What could it possibly stand for? The plus 1 in this first equation, y equals negative x plus 1. Anyone know what that stands for? I can give you a guess. If we use 0 for x, we could get rid of this x, and then the y would equal a 1. Chordatatus. I actually don't know what that word is, Daniel. Jojo, y-intercept. Yes, that's correct. 1 is the point where this equation will cross the y-axis. And with a slope of negative 1, that means we will be decreasing 1, going down on the y-axis 1 coordinate, and then to the right 1. So using these 2 points, I'm going to draw a line as straight as I possibly can. And I'm going to do this slowly so that I don't miss any points and try to draw it as straight as I can. And the other way as well. And you should be doing the same in your workbook right now. If you have a straight edge, a ruler, a book next to you, even your phone, you can use that as a ruler to help you create a straighter line. So always coordinates. Yes, coordinates. That's correct. You spelled it wrong. All good. We love spell check, don't we? This next equation, x minus y equals negative 3. I'm going to change the color here. X minus y equals negative 3. How could we possibly graph this equation? This time, the slope is a little more difficult to identify. So instead of looking for the slope, what can we do to do this? Yes, Daniel, you spelled it perfectly the second time. Coordinates, amazing. Y equals x plus 3. Yes, that's actually correct. We can rewrite this as y equals x plus 3 because we can move this negative y to the other side, making it a positive y. And we can move this negative 3 to the other side of the equality and make it a positive 3. Make them equal. Jason, I see where you're going. Wow, you're going in such a great direction here. You're way ahead of the game. We're going to get there in a couple slides, and you're going to be mind blown. Yes. Jojo, change the order. Yes, that's exactly what we're doing. Amazing. Okay. Once we do that, we would get y is equal to x plus 3. Now, I'm going to show you a different way without having to isolate the y. I'm going to show you a different way of identifying what to graph for this equation. 0 is our favorite number when we are working with linear equations. If we plugged in a 0 into the x, if x is equal to 0, then we would have negative y is equal to negative 3. Well, notice that on both sides of the equality, we have a negative. So that gives us y is equal to positive 3. So when x is 0, y will equal positive 3. Boom, there it is. There's 1 point. Now, since we let x equal 0, what do you think our next thing will be here? What should we do next? If we just set x equal to 0, what should we try next? Y equal to 3. BK, welcome. Y is equal to 3. Yes, we can do that, but we already know when y equals 3, x equals 0. So I like the way you're thinking. But if we made x equal to 0 first, we can try. Jimmy, yes, y equal to 0. Yes, I love that you're all saying y is equal to 3. But if we did plug in y equals 3, let's actually do that to see what we get. We would get x minus 3 is equal to negative 3. And then we'd add 3 to both sides. And that would become 0. So that's exactly what we got here, right? We want to further our progress in this problem. So we're going to set y equal to 0. When y is equal to 0, we get x minus 0 is equal to negative 3, and therefore x will equal negative 3. This gives us the point negative 3, comma 0. I love how we're getting there. Amelia, Jason, love this growth. Love this progress. We're all about the growth mindset here, all right? Even if you don't get it right away, I believe wholeheartedly you are going to get it eventually. By the end of this lesson is never too late. So we have negative 3, comma 0. We're going to connect these points as best as we can. We're sketching this equation, and you might already be able to tell where these two lines meet. Right here. This beautiful point where these two lines meet will be negative 1, comma 2. And this is what we will call our point of intersection, because that is where our lines intersect. Oh, does this give us a right angle as well? That is a great observation, Daniel, and you are actually correct. Amazing observation. Just by looking at it, right? Because we graphed it so well and it's so clean, and this is a beautiful graph, we have this right angle. Amazing. And we're going to learn more about that in Algebra 1 as well. How do we know it's a line and not a curve? Great question, Amelia. We know this is a line and not a curve because we have y and x are both to the power of 1. When we just have the variables by themselves, just two variables by themselves like this, we can always graph it as a line, a linear equation. Great questions. Keep the questions coming, by the way. No question is a bad question. The moment you think of a question, just type it, right? Even if it's past what we've already done, I'm going to answer to the best of my ability. Great questions. Okay, so our previous example worked out nicely, but would you agree that there are more points on the coordinate plane that are not easily plottable? For example, these two lines, it's more likely that this happens than our previous example. These two lines intersect at this point right here, but look at these disgusting points, right? These numbers and decimals probably continue to go past this. This is all that the computer could grab on my screen. So let's investigate. What does a point of intersection imply? In the previous slide, we graphically solved for the point of the intersection, negative 1, comma 2. Exactly, Nabil. This is way too many numbers. We want to make this easier for ourselves. We have these two equations, right? This is what we just worked with. This means the two equations share a point. What does that mean? When two equations share a point, what do you think that means? If two equations share a point, that would mean the point is on maybe both equations. Maybe the point makes either of the equations a true statement. They intersect. Exactly, Daniel. They intersect, and that's when two equations share a point. Let's get into the fun stuff now. We're going to do this same problem all over again, but using our new method, substitution. Since a point of intersection means the two equations have the same x and y value, we can substitute from one equation to the other. So let me ask you this. What do you think our first order of business here is? We have y equals negative x plus 1 and x minus y is equal to negative 3. What would be our first order of business here? We have y equals negative x plus 1, x minus y equals negative 3. Rearrange! Yes, we can rearrange, but do you notice any variable that has already been rearranged for us? Is there any variable that's already isolated for us to use? Any variable that's already isolated for us to use, either the y or the x. Y? Does everyone agree? Is the y already isolated for us? In which equation? The first equation or the second equation? Is the y already isolated in which equation? 1 or 2? The first or the second? Why is it? Why? Tell me why. Are we? Am I? Did that just age me? Does everyone know the Backstreet Boys? Everyone knows the Backstreet Boys, right? That's the Backstreet Boys, right? Yes, I think so. Oh no. We can isolate any. Yes, we can isolate any of the two variables, but in this case, the y, you can tell, is already isolated for us. So why not use it? Y is equal to negative x plus 1. So what this means is that the y and the negative x plus 1 are interchangeable. Eddie does singing. Watch for that social. Coming soon. Coming soon, y'all. Eddie does singing. So since y is equal to negative x plus 1, what if we plugged in, we substituted negative x plus 1 into this y in the second equation? Let's try that out. So now we have, back to my yellow. I love using yellow on this darker background. It just stands out so well, doesn't it? X minus, we have a negative x plus 1, and that's equal to negative 3. But something seems off here. What seems off here? Something's missing, but I can't tell. Help me out here. Can you sub the other way? Absolutely, we can sub the other way, and we're gonna do so many problems together today. I'm gonna ask you, which one do you want to sub later? And you get to choose, so look forward to that. Double negatives, yes, double negatives. But what's happening here? Parentheses, Amelia, you're on top of the game today. Parentheses, where should the parentheses go here? Y is equal to negative x plus 1. We just plugged in negative x plus 1 into the y. Where should the parentheses be? Amelia goated, yes. You're right, Daniel noticed it too. Ooh, should the parentheses go here, like this? Yes, Daniel, I saw you too. I see you. Great work. Should the parentheses go around the x plus 1? Or, since the x is negative, should we have... Oh, great, Amelia. It was a typo. You got it. We want to put the parentheses around the entire thing y is equal to. And now, this is to ensure that we are distributing this negative into everything that's equal to y. And in this case, y is equal to all of negative x plus 1. So we have to ensure to protect that and distribute this negative to both the negative x and the positive 1. Once we do this, oops, I think this went away. A negative times a negative is a positive, and a negative times a positive is a negative, and we have something like this. What's x plus x? Wow, Amelia had it ahead of the game. X plus x is 2x. And once we bring this negative 1 to the other side of the equality, we get negative 2, because negative 3 plus 1 is negative 2. Great, Jojo. And then we divide both sides by 2 to get negative 1. Great, Daniel. 2x, that's correct. And our final answer here will be x equals negative 1. Are we done? Great, Nabil. All good, Amelia. Don't worry. It's just a typo. You got it eventually. That's all that matters. Make all the mistakes you want here, right? Nothing is graded. You're not, I'm not crossing out any of your answers. Feel free to make mistakes, because when you make mistakes and you fix those mistakes, man, that's when the learning really happens. It's all of brain research. When you make a mistake and you fix it, you're building new synapses in your brain, and that's when learning really sticks. So I'm really happy when you make mistakes. Make all the mistakes you want in this class. You're starting to like math now? Amazing, Amelia. Love to hear it. So x equals negative 1. Are we done with this problem? It kind of feels like something is missing. Maybe reread the problem to see what we're looking for. It says, since a point of intersection means the two equations have the same x and the y. Great, Daniel. Great, Jimmy. Great, Amelia. We need to find, and Jojo, we need to find that y value. X is equal to negative 1. Well, since these two equations share the x equals negative 1, we're allowed to plug it into either one of them. So let's do a little bit of a democracy here. Let me give you a little poll. If x is equal to -1, which equation would you like to plug this back into? Equation 1 or equation 2? Let me know in the chat. And whichever gets more votes, that's what we'll plug in x equals -1 into. We have x equals -1. We're plugging it into either equation 1 or 2. Let me know which equation you would want to plug that x equals -1 into. All right, well, all right, great. Sorry, Jojo. It looks like 1-1, but just for you, we're going to do both. Let's try equation 1 first because it got more likes. 1 says y equals -x plus 1. So we're going to plug in x equals -1. So we have y is equal to negative. We're going to be plugging in this -1 in for the x and add a 1. Therefore, what do we get? Negative times a negative is a positive, plus the 1. What do we get? Just y equals negative times a negative is +1 plus the 1. Y will equal. I see how you got 0 here because -1 plus 1 is 0. Well, let's rewrite this. -1 times a negative will be a +1. And then add the 1. Love that, Jojo. You're learning here, right? Mistake, fix, learn. Don't be sorry. Thank you. Thank you for making that mistake because you fixed it now and you're learning, right? Doesn't it feel great? You didn't get it the first time, you fixed it, and now you have it. And now you have it in your brain. Your retention rate just skyrocketed, right? Amazing. Thank you for participating. And I see Amelia, Jimmy, Daniel. Great. Amazing. So y is equal to 2. And for Jojo, we're going to try equation 2 as well. We're going to plug into the second equation x is equal to -1. And when we plug in -1, this is what we get. We plug in -1 into the x, and now we're going to try to isolate the y. We're going to solve for the y, so we bring the -y over to the right, and we bring the -3 over to the left side of the equality, and that'll be a +3. And believe it or not, we get the same y value. We are not done with the problem until we put the two values, x and y, into coordinate form. So this is our final answer. This is the coordinate point where the two equations intersect. -1, 2. Amazing. We got there, y'all. We got there. This is just our first problem. We have a couple more going. So let's get into the next problem. Solving systems of equations using substitution will be extremely useful in every math course after Algebra 1 when graphs of equations start to curve. Right now, for today's lesson, we're only going to be focusing on linear equations, just straight lines. But later on, functions are going to start to curve. And when they do start to curve, substitution is going to become so useful. And using substitution, let's look for the solution to this following system of equations. Now, in the chat, what variable, it looks like x plus y equals 5 is the one where we want to rearrange or isolate a certain variable. Which variable would you like to isolate, x or y? We have x plus y is equal to 5. Which variable would you like for us to isolate, the x or the y? Daniel says x. We'll go with x. X plus y is equal to 5, and if we want to isolate the x and we move the y to the other side of the equality, we get 5 minus y. And right away, the next thing we want to do, well, we have an x, and that's equal to 5 minus y. What should we do? Based on our previous example, what should we do with this information we have now? X is equal to 5 minus y. We just isolated the x, and we know that it's now equal to 5 minus y, and we still have that other equation. So maybe we could use the x being equal to 5 minus y and identify where the x is in the second equation, possibly. Does everyone see the x in the second equation? Yes, we need to plug in 5 minus y in the formula. Which formula? The first one or the second one? Like x plus 5 minus y is equal to 5? Yes, we can absolutely do that. That's a great idea. But notice how in the first equation, we just manipulated that to what we wanted. Could we possibly plug it into the second equation? Do you see this x right here? Because what you said is perfect as well. We can plug in 5 minus y back into this x, but then we just get the same equation. Yeah, let's try plugging in 5 minus y into this second equation. Yes, Amelia, we're getting there. Love that. Growth. 2 times we have 5 minus y plus the 3y is equal to 17. We only need the y now. Yes, we now have an equation with just the y, and we're able to solve it. This goes back to our kind of foundational lesson of how if we have just one equation with 2 variables, we cannot solve for either of the variables. However, if we have 2 equations with those same 2 variables, we can now solve for both variables. And that's what we have here. That's what we call a system of equations, because we have a pair of equations. Amazing. I get it now. Amazing. I know Daniel's fast with it. Daniel's just zooming ahead. Love to see it. So 2, we're going to distribute to both. 2 times 5. We have, what do we have? 2 times 5 is, and then we have 2 times negative y as well. So we're going to distribute the 2 to both the 5 and the negative y. 2 times 5 we have is, great, Daniel, Jojo, amazing, 10, and then the minus 2y. Plus 3y is equal to 17. And now we combine like terms. Negative 2y plus 3y is y. We move the 10 to the other side of the equality, becomes a negative 10, and y is equal to 7. But we are not done yet. We found the y value. What should we do with this to find the x value? We just found the y value. What can we do to look for now its corresponding x value? Plug in. Exactly. Great, Jojo. We want to plug in y equals 7 back into the original equation. And for this one, I'm going to choose for us x plus 7. Yes, I'm going to choose for us the first equation. So we have x is equal to, I'm going to go back in yellow. We're going to say x is equal to 5 minus, that's 7, because we're plugging in y equals 7 into this y. And we have x is equal to negative 2. So our final answer will be negative 2 comma 7, and that is our point of intersection for these pairs of equations. Amazing, Daniel. Amazing, Jojo. Amazing stuff. Great. If we're making mistakes, if we're learning here, that's awesome. We have a couple more examples that I want to show you. Let's keep it moving. Using substitution, solve the following system of equations. Which equation would you want to rearrange here? 1 or 2? Which equation would you want to rearrange? The first one looks like both the x and y have a coefficient. A coefficient is just a number in front of the variable. The x and y look like they have a 4 and 3 out front. But the second equation looks like, the negative y looks kind of nice. Yes, Daniel and Jojo, amazing. Let's work with that second equation. We can isolate which variable in the second equation, the x or the y. Which would you prefer? Second is easier. Yes, Amelia. Second definitely looks easier, but which variable would we want to isolate here? Yes, the y. Let's isolate that y. We want to make the y positive. Great, Daniel. Great, Jojo. We want to make that y positive. We're going to add the y to the right side. And when we move the 1 over to the other side of the equality, it becomes a negative 1. So now I have 5x minus 1 is equal to y. We have isolated the y. We have rearranged the second equation to get to y. Now let's utilize this information to solve and plug into equation 1. I identify the y in equation 1, and that's where I'm going to plug in 5x minus 1. So we have 4x. Wow, Jimmy, you're quick. We have 4x plus 3 times 5x minus 1 is equal to 16. Let's see if we got that correct. We want to distribute this 3 to both terms. And I can tell all of you are just scrambling to try to get the answer before me. That's awesome. 3 times 5x will be 15x. 3 times negative 3 is negative 3 is equal to 16. And now we combine like terms. Great, Jojo. 15x minus 3. Now, when we combine these, what do we get? What's our next step going to look like here when we combine the like terms? We have 4x plus 15x. And it looks like we're going to have to move this negative 3 to the other side of the equality. And what would that give us? The x's together will give us 4 plus 15. That will give us something like 19x. And when we move this negative 3, great Jojo, great Amelia, when we move this negative 3 to the other side of the equality, what could we get? 16 plus 3 is 19. Awesome. Amazing, Daniel. You spelled it out for us perfectly. Amelia, Jojo, awesome. And we know 19 times something equals 19. That something has to equal 1. We're going to use this information to go back and solve for the y. Now, let's think about this for a second before we just, go on about our day and make this just, boring. Which equation would we like to plug x equals 1 back into to make our lives easier? We always want to work smarter, not harder. Which equation would we want to plug x equals 1 back into? The first equation or the second equation? Sorry, trick question. It doesn't matter, right? Amy says 2, Daniel says 1. Doesn't matter. Why? Because we know that both of these equations share that x equals 1. So whichever equation we plug this back into, we should get the same exact answer. But for the purpose of this problem, I'm going to use the already isolated y and plug in 1 into the x up here. So we have 5 times a 1 minus 1 is equal to y. And we have 5 minus 1 is 4. And looks like all of us got y equals 4. Love the emoji. Got it. Y equals 4. Daniel, Jojo, Amelia, Amy. A+ for y'all today already. X equals 1. Y equals 4. Our final answer. Never forget. What do we have to write it out as? Never forget. What do we have to write this out as? We have x equals 1. Y equals 4. We want to write it out. I see you looking for the parenthesis sign, looking for the comma, the chords. Yes, the coordinates. Yes, Daniel. We have to write it as a coordinate point. 1, 4. Beautiful. Well done, everyone. Let's keep going. Let's challenge ourselves a little bit here now, right? Let's challenge ourselves. Here is a tougher one. A little bit tougher, but don't worry. We're going to go through this step by step together. Great, Daniel. I see the 1, 4. You might have missed the parentheses near the end, but I know you got it down on your paper. Amazing. Using substitution, find the solution to the system of equations 2x plus 5y is equal to 10 and 3x minus 4y is equal to 15. Which equation, number 1 or 2, would you like to isolate? And tell me which variable as well. Tell me the equation number that you'd like to rearrange and which variable you'd like to isolate. Think 1. Okay, Amelia says 1. We're going to work with 1. Oh, Jimmy says 2 and 1. Daniel says 1 as well. Okay, we'll work with 1. Which variable should we try to rearrange? I see Daniel spamming 1 here. Spamming 1. Okay, let's try 1 for this problem, and maybe for the next one, we'll try the second one. 2x plus 5y equals 10. Which variable would you like to isolate here? X or y? Love the enthusiasm, Daniel. Which variable, x or y, which variable would you like to isolate for this problem? Equation 1, x or the y? I'm going to go with the first response in the chat. 2x plus 5y equals 10. Which one would you like to rearrange? And this one looks a little new, so I'll try to take you step by step through this one. All right, Daniel says x. Let's go with x. So for this one, whatever Daniel wants, Amelia. Great. Eden also says x. Awesome. So we have 2x. I want to isolate it, so I'm going to bring the 5y to the other side. We have 2x is equal to 10 minus 5y. And now, in order to isolate this x, I have to divide both sides by 2. But we have to be careful here. We have to make sure to divide everything on the right side of the equality by 2. So 10 divided by 2 is 5. And we also have to divide the negative 5y by 2 as well. So we have negative 5 over 2y, just like this. From here, we have an x equal to some other box. X is equal to this. So what if we plugged in whatever x is equal to into the x in the second equation? Let's try that. And reminder, what can we never forget when we are plugging in something into a variable? What can we never forget? When I'm plugging in something that's equal to a variable into the variable in the other equation, what can we never forget? Amelia, yes, parentheses in all caps. Yes, never forget the parentheses. And from here, we want to distribute the 3 to both. Yes, parentheses. Love it. Distribute. Yes, Daniel, that is our very next step. We want to distribute the 3 to both the 5 and the negative 5 halves y. We have 15 minus, distribute the 3. Yes, Daniel. We have 15 halves y minus 4y is equal to 15. Now, I want to pause here because I recognize something. I want to see if you can identify it too. What do we notice here? We want to combine like terms. We have two terms that have a y. And what are our numbers here? What do you notice about our numbers? Like terms. We have a 15 on the left side of the equality. And what do you notice on the right side of the equality? Another 15. So what does that mean for us? What does that mean for this equation that we're working with? We don't have to do all the work. Yes, great, Daniel. We do not have to do all the work of combining like terms with the y because we know that the other side of the equality is going to be a 0. Yes, Amelia, right? On the right side of the equality, there's also a 15. So what does this mean for the y? What does y have to equal here? Without doing any more work, what does y have to equal here to make this equation true? Y has to equal 0. 0, 0. We love having 0 as an answer because it is one of the easiest numbers to work with. Yes, 0 times anything is 0. We love 0. And now that we have 0 for y, we can solve for x. Donut, yes. We can solve for x. We're going to plug in y equals 0 into whichever equation you like. Since we started with equation 1, let's work with equation 2 next. Love the enthusiasm. Yes, 0 all the way. We got 3x minus 4y is equal to 15. This is our second equation, by the way. And we're going to plug in y equals 0 into this equation. And as Amelia told us earlier, never forget your parentheses. We have 3x is equal to 15 because anything times 0 is 0. And therefore, x is equal to 5. Don't forget our final step. We have to put our answer in coordinate form. 5, 0. Finito. Great. That is our point of intersection, right? Never forget. We might get a little lost in the sauce here with all the algebra, all the fun of plugging in, finding 0, but never forget what our final answer really means. Right? There's always meaning to our final answer, and we want to find that meaning. And in this case, or in all the problems that we're solving today, our final answer, our coordinate point, is the point where the two systems, where the two equations in our system of equations will intersect. They intersect at exactly one point, 5, 0, and that's a beautiful thing. This might be our last practice problem before we get into an application. So pay close attention. This one looks a little more difficult. Yes, I love the emojis. 5, 0. I see Daniel, Amelia, Jason. Y'all are amazing. Participation is key. You want to try to participate as much as you can. Make your mistakes. And when you start getting it right, like we all are right now, It's a beautiful thing. That's what learning is all about. Having fun, building confidence, and just killing the game. Let's try this one. We have x over 2 minus y over 4 equals 1/5. 7x plus y is equal to 1. Now this one's a little different, right? We have fractions in our first equation. And whenever we're working with fractions, it can be a little intimidating. So I'm going to give you a little trick here. Here's a little secret. I'm going to get rid of those fractions first. I'm going to get rid of all of those fractions. Yes, believe it or not, those 2, 4, and 5, they are not going to be there in a little bit. And what can we do to get rid of them is the big question. If you know, drop it in the chat. But if not, I'm going to get into that right now. We have x over 2 minus y over 4 equals 1/5. In order to get rid of all of these denominators and make it look like what we've been working with, I'm going to multiply both sides by the least common multiple, the LCM of the two numbers 2, 4, and 5. This is getting quite tough. Yes, this is the most challenging it gets. If we were at level kind of 2 or 3 before, this is the highest level, level 5 for our systems of equations using substitution. And when we get this, oh, it's going to be so sweet. So stick with me here. Least common multiple for 2, 4, and 5. What's the smallest number that has a factor of all three of these numbers? Let's think. Maybe 10? Maybe 10? 10 is divisible by 2. It's divisible by 5. But not divisible by 4. So not 10. Maybe 15? Well, 15 is not even, so it's not going to be divisible by 2. What's the next number? Jojo said it. 20? 20 is divisible by 2, divisible by 4, and divisible by 5. So what if, great Amy, we multiplied both sides of this first equation by 20. Let's see what happens. If we do this, 20 times x over 2. Well, half of 20 is 10, so now we have a 10x. Our next one, 20 times a negative y over 4. 20 divided by 4 is 5. Don't forget that we still have this negative in front. So we have negative 5y is equal to a fifth of 20. So basically 20 divided by 5 is 4. And now look at that. We have an equation now that's the same thing as the equation we started with, but now it looks a lot more friendly. And we just did that. We really just did that. And now we have two equations that we can work with. Let's call this 7x plus y equal to 1. So we have our first equation and our second equation. Clearly, we want to isolate the y. So let's isolate this y in the second equation. And that'll give us, once we move this 7x to the other side, 1 minus 7x. Now, what can we do with this? We've been doing this all lesson now. What can we do with this information? We have y is equal to 1 minus 7x. Oh, Daniel already got it, giving us spoilers. We love spoilers. Y equals 1 minus 7x. What can we do with this information? Daniel, help us out. Since you already got to the final answer, what can we do? I actually don't know if it's right or wrong. We're going to figure that out right now together. Y equals 1 minus 7x. What can we do with this information? I know, Daniel's fast. Jojo, Amy, I know Amelia's still here. Jason, Jimmy was here earlier as well. You might be right, Daniel, but we're going to figure that out together. What was the first step you did here, Daniel? How did you get it so quickly? Or anyone else who wants to chime in. Y is equal to 1 minus 7x. What can we do with this information? What can we do with this 1 minus 7x? I notice that there is a y in our first equation as well. So would it be okay to take this 1 minus 7x, take this 1 minus 7x and plug it in into the first equation? What if we do that, right? Then we'll have our first equation, 10x minus 5 times the 1 minus 7x is equal to 4. And we simply distribute from here. Yes, plug. Yes, the plug. We got negative 5 times 1 and negative 5 times negative 7x. Yes, Daniel, I know that's exactly what you did. Amazing. So once we distribute, we would get 10x minus 5 Amazing. Jojo? Yes. Too hard to type. Yes, I know. Typing math is pretty tough, right? Typing math is pretty tough. -5. Great. I see you. That's what you meant. -5. Awesome. And -5 times -7x. What would that be? -5 times -7x. We're distributing this -5, and we're making sure we distribute it to both terms, or all the terms in the parentheses. Yes, great, Jojo. -5 times -7x. A negative times a negative is a positive, and 5 times 7 is 35. Amelia, great, you got it right eventually. That's all that matters. We got plus 35x equal to 4. Amazing, lots of things to celebrate today. We're gonna combine like terms. We have 10x plus 35x. What does that give us? Nice, the 5, yes. The 5 will be nice as well. 10x plus 35x will give us 45x. Move, yes. And move the -5 to the other side to make positive. I know that's what you mean, Jojo. We get 9. When we divide both sides by 45, we get 9 over 45. And using our knowledge of fractions and simplifying, we know that 9 and 45 have a common factor of 9. And therefore, we can cancel out a 9 from both the numerator and denominator, and we have our x value. Simplify, yes, exactly. Simplify the fraction. That's another way to say it as well. Thank you, Daniel. Yes, Daniel, I saw you got x equals 1/5 earlier. Amazing. Now let's check to see that you got your y value correct as well. And I think you are correct. Let's check it out. We're going to plug it in into y equals 1 minus 7x, our second equation. Plug in x equals 1/5. I know Jojo loves to plug in our variables back into the equation. We'll get y is equal to 1 minus 7 times 1/5. And don't forget about multiplying our fractions. And we get, since 1 is the same as 5 over 5, common denominators, right? This is all stuff that we'll be talking about at the beginning of our Algebra 1 course as well as refreshers. And it's easy now, yes. Y is equal to -2/5. But don't forget, our final answer always has to be in coordinate form. Boom. Daniel, you got it so quick earlier, and you got it correct as well. Kudos to you. Respect. Amazing. I see Amelia. Wow. Yes, we did it, right? When we first looked at this problem, it looked a little challenging, a little intimidating. We were scared to start. But once we just took that first step and we were like, what if we got rid of these fractions? Everything just started flowing, and that's a great feeling. Learned a lot. Yes, we have one more problem here, and that is our application problem. Jojo, I see you got -2/5 as well. Thank you, Amy. Explained it much better than in school. I wish I could be teaching at your school as well. Let's check out this application. Charlie, this is how systems of equations can be used in real life, and for maybe in your future as well, because I'm sure all of you, you're going to be math geniuses if you take math with me, and you're going to get paid, right? And let's take a look at this application. Just so you can take care of your finances, you can get the best job that's best for you. Charlie, your friend, is offered a job by 2 sales teams. Team A offers a salary of $42,000 plus a commission of $10 per sale. If you're not familiar with what a commission is, it's the amount of money you get per every time you sell the product that your team is selling. Team B offers a salary of $35,000 plus a commission of $25 per sale. So let's write these down. So we have Team A. Charlie has Team A and Team B. Got offered jobs from 2 different sales teams. So Charlie's probably really good at interviewing. He got 2 offers already. Team A offers a salary of $42,000. Boom. That's a solid salary. A salary is how much you get paid within a year. $42,000. Team B, Charlie would be getting paid $35,000. So just based off of this, which team would you want to be a part of? Would you want to take the offer from Team A or from Team B? Which one sounds a little more enticing? Daniel says B. You want to take Team B even though 35,000 is less than 42,000? Oh, okay. You meant A. Great. 42,000 is greater than 35,000. I know they're bigger numbers, so they might have been a little difficult to differentiate. But 42,000, right? Much more than B. But let's check out the commission. For team A, you'd be getting $10 per sale. And I see, Jason, you said sale equals S. Let's use S. That's a great idea. And for team B, we're adding $25 per sale. And both of these are equal to some total earnings. So total earnings we will call T for total. Now this one looks very simple compared to the ones we've dealt with, right? And that tends to be the case when we learn new things in math and we try to apply it in real life. Things tend to get a little simpler. We have T is equal to something in team A, T is equal to something for team B. So what if we just set them equal to one another? We have 42,000 plus 10S is equal to 35,000 plus 25S. And now we can just combine like terms. I'm going to go ahead and wrap this one up for us. We're going to combine like terms. 42,000 minus a 35,000 would give us 7,000. And when we subtract 10S from both sides, we get 15S. And I'm going to tell you just off the top of my head, if we divide both sides by 15, yes, with the sales, like terms, amazing, Jojo and Daniel. If we divide both sides by 15, we're actually going to get 466.67 sales. So if you were to approximate this, that would be about 467 sales. So now, which offer should Charlie take? It's going to take 467 sales. There are 365 days in a year, and if you don't work on the weekends, that's less than 250 days in a year. And they want you to make at least then probably around 2 sales per day. So unless you're going to be there for a while, unless you're committed to this sales team, we love commitment, by the way. In the short run, you would want to take team A. But if you're there and you're committed, then you want to take team B. So it really depends on your situation. Maybe you're just in the city for a little bit. You don't have much time and you just, want to take, the best you can get, go with team A. But if you're settling down, take team B by all means. That commission is going to work wonders. All right. If you're still here with me and you enjoyed this lesson, put a plus in the chat so that I know you're still here. And call your parents or guardian or the nearest adult closest to you. Call them over to the screen. I have something really special to share with you all today. Something really special. Put a plus in the chat if you enjoyed the lesson. Call your parents over. I see Daniel, Jojo, Amelia, Amy, Jimmy still here. Let me share with you something really special. It's the first time you like math. Amazing. Thank you, Amelia. Our lesson may be ending, but your progress doesn't have to. At my EddSpace, this Algebra 1 full year course will start on October 6th, and each course is going to include 2 engaging live and interactive lessons each week. So the one that you just got, this lesson, you're going to get 2 of these each week. And for Algebra 1, it'll be on Tuesdays and Thursdays, 5 to 6 p.m. Pacific time. Unskippable ad. Great. 5 to 6 p.m. Pacific time. So basically the same time we met today, Tuesdays and Thursdays, starting on October 6th. All these lessons will be recorded. So if you ever miss one because of extracurricular activities, you can always come back to them. And you'll always have those professionally designed workbooks as well to follow along in these lessons. Furthermore, something you didn't get today, but you will get if you decide to start your journey with me at my EddSpace, you're going to get practice problems with exam-style questions. And don't worry about getting your answers correct or wrong, correct or incorrect. You'll always have detailed video solutions made by me solving all of those practice problems in front of your screen so that you can check your work. But how much is it? For context, when I used to be a private tutor, can you guess how much per hour I used to charge my students? Per hour, how much do you think I charged? Yes, I will be the one teaching this course. How much do you think I charged per hour to all my students when I used to be a private tutor? I see Amy says 80. Amelia says 150. Daniel says 123. Love the exact numbers. Jojo said 10. Wow. We have a wide range, all the way from 10 all the way to 150. I used to actually charge a minimum of $100 per hour. Hi, Pearl. Welcome. And I see Star Pause is back as well. $100 an hour minimum, and I charge up to $200 as well. But families, when it comes to private tutoring, always have to choose between what works and what they can afford. They always are forced to choose between affordability and effectiveness. And that's why we created My EdSpace. You get all this: engaging lessons, video recordings, workbooks, practice, detailed video solutions, and all of that, hi Samantha, welcome, for $99 a month, which is 8 times cheaper than what I used to charge private tutoring. And why stop there? Because you're here today, I'm giving you a special offer. 20% off additional discount on your annual package. And to protect you from any risks, we provide a risk-free 30-day full refund guarantee. But we do have limited spaces, so it is going to go on a first-come, first-served basis. It's a special limited time offer, and if you're interested, text me code word START to this number. Get your phone out, scan this QR code, and it should prompt you to send that code word straight to this number so you don't type in that number incorrect. If you don't know how to get this working yet, just take a picture of this, send it to your parents, call your parents, say, I really enjoyed today's lesson. Please, I want to learn with Eddie. And as soon as you do so, you'll get your journey started with me, EddieDoesMath, at My EdSpace. So go ahead, scan this QR code, do what you have to do to join the course to start your journey with me. I have some time for Q&A. So if you have any questions, I'll try to answer to the best of my ability, but I'm going to keep this on the screen so you can get this seriously special limited time offer. Ask my dad right now. Great, Amelia. Love that. Amelia said, how can I buy this? How can I join? Text me, code word START, and we're going to get you started. Do I have Korean classes? That's a great question. Maybe that's something we can work on later. But right now, I just love teaching math so much. I like to focus on math. Math classes are the most important. It is a primary subject, right? Math and English. Everyone needs help with math, and I'm here for you. Are you on any of the vendor lists for homeschools? That's a great question. Text me, and maybe we can talk about that as well. It would be $99 a month. And we can talk more about that. But as I said before, because you are here, you will get a special 20% additional off on the annual package. So just text code word START to this number, scan this QR code, and we can get discussing on that. Yes, I will be teaching all of the classes. I teach grade 6 through 8 math, Algebra 1, Geometry, and Algebra 2. All 4 courses, and they all start on October 6th in a little over a month, and you're going to get everything. Thank you for helping me today. Hi, Giovanni. Really appreciate you. I didn't get to see you in chat, but I'm really glad you joined in at the end. Thank you for joining today. And I look forward to speaking with you via text. You want to be on the next lesson? If you want to be on the next lesson, you can sign up. The link should be in the YouTube description. If not, follow me on socials, EddieDoesMath on Instagram, TikTok. Again, EddieDoesMath. Follow me on Instagram. Keep up the interaction. If you want to keep interacting with me online, on socials, it's going to be a great time. Speaking to your dad right now, and he says he thinks it's worth it. Amazing, Amelia. I'm looking forward to texting you in our chat thread. Send that code word START to the text, scan the QR code, whatever you need to do to start your journey with me at My EdSpace. Yeah, you definitely don't want to miss out. Thank you, Jojo. Thank you, Daniel. Yes, Daniel, when is it? So for Algebra 1, the course will start on October 7th. That's a Tuesday. And it will be every Tuesday and Thursday, 5 to 6 p.m. Pacific time. So exactly the time we had our lesson today on Tuesdays and Thursdays, starting on October 7th for Algebra 1. Scan now. Amazing, Amelia. Looking forward to speaking with you. Thank you, Jojo. Thank you, Amy. Join all my lessons. Yes, Amy. Looking forward to learning with you, growing with you, showing you the beauty of math. Hopefully you learned something new today, and hopefully you get to learn even more things with me in the future. Does it prepare for exams? Yes, it should prepare for exams, not specific exams, but after this course, I can assure you that you will be ready for any exam that involves Algebra 1. Mom said yes. That's amazing, Daniel. I look forward to seeing your text to my number later on. Yes, amazing. Yes, we could be friends in this Wow, we already have friends in the chat. Amazing. I look forward to seeing you, Amelia, Jojo, Daniel, Giovanni, Pearl, Starpaws, Jimmy. Looking forward to seeing you all again. Also, what grade is this usually for? Great question. So Algebra 1 usually tends to be taught anywhere from starting 8th grade to 9th grade. But more advanced students could take it even in 6th and 7th grade. But doesn't matter what grade level you are, I am teaching Algebra 1, the course. Yes. So it doesn't matter what grade level. If you're struggling with Algebra 1, taking Algebra right now, you're not getting enough at school, you can trust me with this. Get your journey started with me. Alrighty. Yes. We can all be in the same class together starting on October 6th. Looking forward to all your texts, and I'm so excited. I'm so excited for you to get started on this journey because it's going to be amazing. It's going to be hype. Oh man, I'm so excited to see you all again in chat, and thank you for joining in today. If you have any questions at all, again, my socials are EddieDoesMath on Instagram and TikTok, and we can interact there as well. But more importantly, make sure you scan this code and text me, and I'll see you next time. Thank you, everybody. Bye, Giovanni. Bye, everyone. Thank you. Bye, Jimmy.